Thank you very much, and good morning, everyone. Excited to have you all here, and I hope you've all had enough coffee. My name is Conrad, and I work in one of the infrastructure teams at SoundCloud here in Berlin. And at SoundCloud, we operate a sizable data center, and we also use a lot of open source software. So I was actually a bit disappointed that we just this year found out about this very conference right here at our doorstep. However, now that we did, we figured maybe we even have a bit to contribute here. Because not only do we use a lot of open source software, we occasionally also create some. And one of the more noteworthy occasions in the recent past, or as someone actually phrased it over a beer last night, one of our more successful products, is certainly the Prometheus monitoring system. So, as a company, we're still heavily invested in the Prometheus project, even though it has by now grown up to become a CNCF project. And as such, we recently made a move to migrate all our infrastructure monitoring from various other systems to Prometheus. And we thought that is something that others might be interested in as well, because Prometheus has traditionally been very much focused on application-level monitoring. So this talk is a bit about this migration and what we did and how we did it and the challenges you'll still face along the way. So let's dive right in. I'll first give you an introduction to our data center, just so you know what we are up against in terms of monitoring and the scale we operate at. I'll then give you a very brief introduction to Prometheus, which would rightfully be a talk of its own, so it'll also be a bit dense. I'll focus on the most relevant aspects for this presentation. And don't worry if some of it doesn't immediately make sense, because it's mostly intended to give you the right Google keywords to follow up later on, if you like. In the main part of the talk, I'll go through all the exporters and integrations that we used and partially even created along the way to achieve this migration. And then, as is customary, I'll give you an outlook and summary kind of thing. So let's start with our data center. It goes by the name of AMS5, and as you can probably already infer, it is located in the beautiful city of Amsterdam. And I'm telling you this just to emphasize that if something breaks, we don't just go to the data center and fix it. We have to tell a team of remote hand engineers employed by the data center operator precisely what to do to fix or replace hardware for us. So we really heavily rely on monitoring to know what's wrong in the first place. In this data center, we have a total, or at least at the time I created this presentation, of 2,118 servers. And I'm giving you this oddly specific number because, as a little teaser, if you look closely, this is actually a screenshot of a graph, but more about that later. These servers are spread across 56 racks, and this is the actual data center, not stock photos. We have around about 200 network devices like routers, switches, and firewalls to connect all those. And speaking of connectivity, we have 4 peering partners, 2 for generic internet connectivity, and we have quite huge direct peerings with both AWS and Google, because we've been a hybrid cloud and on-premises company for a long time and heavily rely on these links. And yes, we know some of our cabling looks better than others. So all this needs to be monitored. How did we do this in the past? Well, when I joined SoundCloud, you could find mention of all these monitoring-related systems in our infrastructure code. And to be fair, you could say that Isinga and Nagios are basically the same thing. And also Munin, we actually had removed already by the time we started the move to Prometheus. However, you'd find mentions of this and might be a little confusing, for example, for new hires, as to what is being monitored, where, and how. So, what I personally find a little more confusing than just the mere presence of these systems is how they were being used. Because if you break down the job of monitoring into 3 distinct parts, so data collection, visualization, and alerting, you'll see that some of these systems cover the entire spectrum, while others don't, and rely on yet other tools to do that job for them. So to give you kind of a worst-case example that you could encounter back then is you get paged. PagerDuty says it's a Nagios alert. So you think Nagios, then realize, all right, it's actually called Isinga now. So you go to Isinga. The Isinga check that failed actually checks the value in graphite. So let's look at the graphite graph. It looks odd. Where does the data come from? Oh, it actually comes from ganglia. So I mean, this is kind of a bit exaggerated maybe, but if you get woken up in the middle of the night and you have to follow through such a chain of systems, it might make, it takes longer than it maybe should in an emergency. So when this whole Prometheus thing started to take off, we were of course wondering, would it maybe be possible to just, replace all of this with just Prometheus? And whenever someone presents such a list to you and suggests to maybe replace it with just one thing, usually someone, and rightfully so, will bring up this glorious XKCD comic. In case you don't know it, it's called How Standards Proliferate. And it says, situation, there are 14 competing standards. And then someone says, 14, ridiculous, we need to develop one universal standard that covers everyone's use case, and someone else agrees. And then in the end, you have soon, situation, there are 15 competing standards. Now, there's a very important lesson in this strip, and that is, if you were interested in doing such a migration yourself, or actually any kind of migration of this kind, you'd better not do it half-heartedly, because there's a real danger you end up in a situation that is even worse or more complex than the one you started out at. Nevertheless, spoiler alert, it worked pretty well for us. So I will revisit this list at the end of this talk to show you the situation we ended up in. All right, let's take a brief look at Prometheus. Like I said, might be a little dense, don't worry too much about some of the details, and there will be some specific details. Nevertheless, if you get the general idea, reading, for example, the Prometheus documentation should immediately fill in the gaps for you. That said, let's start out lightly. If I had to make a marketing slide for Prometheus, this would be it. What we as the infrastructure team were looking for in Prometheus is a reliable, scalable, yet flexible real-time monitoring and alerting system that is easy to integrate with as many things as possible. Now, lucky for you, this isn't a marketing talk, or only sort of, actually. So let's actually look at some more detail at each of the points that I highlighted. Reliability. Important to point out is that Prometheus operates in a pull-based manner, where one such pull of data is referred to as a scrape, a term I'll be using henceforth. For that to work in the first place, the Prometheus server needs to know about a list of targets that it's supposed to scrape. Now, this might seem like additional configuration overhead, but it's actually worth it, because you can use some semi-dynamic mechanisms to define your targets, like, for example, DNS or service discovery. And if you use the same mechanisms that your services use to talk to each other, which you should, it's actually really nice because the Prometheus server will immediately have the very same view of your infrastructure as all your services. And if something that should be responding isn't responding or not producing any metrics, you'll immediately know something's wrong. On top of that, Prometheus has built-in meta monitoring, so you can easily and extensively monitor Prometheus with Prometheus, which is also really nice. And redundancy is super easy. For example, our team simply has 2 servers that scrape the same targets, and in case one breaks, we just DNS failover to the other one. Also very nice, for example, to test major version upgrades. Scalability. Prometheus is very performant and especially efficient on disk space. I'm just going to put that out here for now. I have some actual numbers later on. It also scales really well to available resources, probably partly thanks to being written in Go, but also thanks to being written well. You can see an HTOP screenshot below. If you put some load on the server, the load distributes really nicely across all available cores. The server is doing nothing but running Prometheus. That said, it also doesn't always use that much CPU because in this situation, we actually put some load on it. It's just to show how well it distributes. Nevertheless, should your resources on one server not suffice anymore, it is very easy to scale horizontally. For example, at SoundCloud, again, every team has their server or their servers mostly. And the reason it is so easy to scale out horizontally is in case you do have any cross-cutting concerns, it is very easy to aggregate certain metrics from multiple servers back into one server by using the built-in federation feature. Flexibility. Now, Prometheus employs what it refers to as a multi-dimensional label-based data model. What this means is that every metric is defined by a metric name and an arbitrary set of key value pairs, the labels. Also by a value, of course, and to be exact, a timestamp, though you're rarely concerned with a timestamp because thanks to being pull-based, this is all handled internally by the Prometheus server. In this model, all data points that have an identical metric name and labels form a time series. And on top of this, you have a powerful query language called PromQL that allows for easy queries and aggregation of metrics based on these labels. Now, that's a bit theoretical, so let's look at a very tiny example. Assuming you have some target to scrape, for example, an HTTP load balancer. And assuming this load balancer were to expose the following metrics. Now, this is the actual data format, so this is something that could be actually scraped by a Prometheus server. You see 4 metrics here, each with the same metric name in white, and they each have the backend and the code label, however, with a different permutation of values, so they're actually 4 distinct metrics. If you scrape this small example with a Prometheus server, you could then run the query below on the server, and what it would do is give you the sum of all the metrics with a given metric name and where the backend label matches the value foo. So in the example above would be the first two metrics. Sorry. You could also omit any labels in the query, and it would give you the sum of all 4 metrics. Or you could use 2 labels or just the code label, and the point is you can use the labels in any way you seem fit, and it will be still equally performant. So, ease of integration. As we've just seen, the data format is text-based. So should you be in the situation to need to create some kind of script or other tools that create such data, it is pretty easy to achieve. Prometheus scrapes are actually just HTTP requests, so should you have to implement that, it's also pretty straightforward. Much more importantly, you rarely actually have to do this because many, many integrations already exist. And in fact, that image on the right is actually a screenshot from the Prometheus website with the list of existing integrations. So it's just to show you that there's quite a few already. Even if whatever you would like to monitor is not in that list, the Prometheus project provides excellent tooling and libraries to create new ones. And we'll also see later on just how easy that really is. Now, the main part of this talk will be about the integrations that we used to migrate all our monitoring to Prometheus. So let's look at some detail about how such an integration is usually designed. In the simplest case, you write an application and you use the existing libraries, for example, to instrument your application so that it can be scraped by Prometheus and returns the metrics you're interested in. However, this doesn't do anything for us in infrastructure because we don't want to monitor applications. We want to monitor servers and network gear. Luckily, there's a second type of integration, which is usually referred to as exporters. These exporters are standalone applications that you run on some host that you're interested in, that you want to monitor. And these exporters will, for you, open an endpoint that Prometheus can scrape. And upon being scraped, they collect the data they are designed to collect. In this example, I'm using the node exporter, which exposes operating system level statistics like memory usage and CPU usage for Unix-like systems. So everything you could get out of proc, for example. Now that's already pretty valuable, of course, for infrastructure monitoring, but what about network gear that we can't run arbitrary applications on? For this, there's another type of exporter which, upon being scraped, will actually employ some other protocol that it was designed to employ to talk to your network gear. A very common example is, of course, the SNMP exporter, which, when you scrape it, it will request from a router all its current metrics via SNMP, transform that into the Prometheus data model, and return it to the server. Now, for these exporters, it's important to point out that you actually use the same exporter instance to monitor all your routers. Nevertheless, there's still a one-to-one relationship of scrapes and targets. So that means, in this case, your Prometheus server still knows there's router A and there's router B. And when scraping, it will tell the exporter which router it is intending to scrape. So, now that we've handled this, there's two more important things for monitoring that we haven't covered yet. One is alerting. Alerts are built into Prometheus and can be defined in Prometheus configuration. However, they don't do much just on their own. For this, there's a separate application that is, however, part of the official Prometheus project called Alertmanager. And it very much does what you'd expect of an application by that name. It manages your alerts. You can silence alerts, and what's pretty fancy is you can do alert grouping and routing based on the Prometheus labels, which is very handy. It also comes with a clustering mode built-in, so it offers high availability out of the box, which is, of course, pretty important for alerting. Now, just as important as alerting is, of course, dashboards and graphs. So we haven't seen those yet. And actually, the Prometheus project is not concerned with that. And the official recommendation is to use Grafana for all your dashboarding and data visualization needs. Grafana is a totally separate open source project, but an awesome one. And it displays data from many, many different data sources, Prometheus just being one of them. So even if you're not interested in Prometheus, you should probably check out Grafana. And what's so nice about it being so versatile is two things. First of all, if you attempt such a migration from one monitoring system to another, you can easily have graphs from one source and from the old source and the new source on the same dashboard, and make sure it all adds up and is what you expect it to be. And the other thing is that there's certain data you should never ever attempt to put into Prometheus, like logs, for example, even though I'm sure someone somewhere has already tried that. For this, you'd probably have something like your Elasticsearch cluster or some other database, and Grafana will happily display data from there as well. So you can easily have a dashboard that displays Prometheus data side by side with, for example, relevant log snippets from the same time, or stuff like this. All right. So now you have a rough idea of what we are monitoring and how Prometheus works. So let's take a quick look at what all integrations we used, and as I already mentioned, partially created along the way when trying to get rid of all the other systems. And for each integration I'll talk about, I'll give you a little tip or trick in case you might venture this way on your own that you might find useful. So let's start simple. I already mentioned the node exporter, and that it exports operating system and partially, I guess you could call it hardware level metrics for running systems. So you have a server, it's up and running, you run the node exporter on it, you can scrape it with Prometheus, and you get a ton of data out of the box. For us, the node exporter mostly replaced Ganglia and also some iSinger checks, some custom checks that we wrote. And what's noteworthy about it is it comes with a ton of collectors built in, so different plugins, if you will, that collect different type of data. And one should point out that only some of them are enabled by default, so if you were going to use it, you should read the documentation to make sure all the collectors you might be interested in are actually enabled. There's awesome stuff like, for example, extended TCP metrics that can be very helpful to debug things at times. Also, I don't know much about it, but I'm told if you want to monitor Windows servers, you should use the WMI exporter instead, which does roughly the same thing just on Windows hosts. So this brings me to pro tip number 1. The node exporter has one specific collector that is a bit special, and it's called the text file collector. And that one is as awesome as it is simple, because all it does is it reads a text file, or actually several text files if you wanted to, in the data format that you've seen previously on the slides, so the one that is actually pretty simple to create, and it will take the metrics from the text file and just return them to the Prometheus server. Very simple idea, but it makes for a great integration point to add your custom metrics. There's actually some example scripts, even in the node exporter GitHub repository, that collect rate controller data, for example, or SmartMon data, and expose that to Prometheus. We also use it for some cron job results, and we also have a certain amount of our chef data, so from our configuration management system, that we expose in Prometheus this way. Very simple to use, but very powerful. Next exporter is the Blackbox exporter. This one is a bit special, as in that you can tell the exporter to send a probe in a protocol of your liking to a random target. The probe types supported, or the protocol supported, are DNS, HTTP/S, ICMP ping, and TCP connect. And you can already see that, for example, with the ICMP ping, this is a prime candidate to replace Smokeping, which we did, and I'll talk about that in a second. Another thing that we found really noteworthy is that it also monitors, for the HTTPS probe type, TLS certificate expiry. So you can actually easily create alerts that will notify you when your SSL certificates are about to expire, which is really handy. So, Smokeping replacement. Now, if you look at your typical Smokeping setup, then Smokeping has some interval, usually around 2 minutes, and every 2 minutes, it'll send a number of pings, say 20, and it will then give you aggregate statistics for the timing and potential packet loss of these 20 pings. Now, the Blackbox exporter is designed differently. Upon each scrape, it'll only send a single probe. Now, to kind of bend that into what we wanted to, we just decided we're going to scrape it really, really fast. So we set a scrape interval of 5 seconds. So we actually have 1 ping every 5 seconds. And if you take that over 2 minutes, you actually have roughly the same amount of data that we previously had in Smokeping. And in fact, we have even more data because we have the exact timing information for every probe. So you can already see where this is going. Once you have that, it is very easy to create alerts that will alert you when the target is down or you encounter a certain amount of packet loss. And then, given the data, you can use some of the aggregation functions that Prometheus offers and slap them into Grafana. And you'll easily get a graph, for example, like this. So the white one is an original Smokeping graph, and the black one is a Grafana graph that we created from our Smokeping replacement data. And it doesn't look quite as smoky, I guess, but it nevertheless conveys the same data, and you actually have even more precise data if you wanted to. But yeah, we don't look at the graph so much. We're more interested in the alerts, of course. So there goes Smokeping. And that brings me to pro tip number 2. If you think it might bring you any value, scrape more and scrape faster, because for Prometheus, that is totally not a problem. Our server scrapes around 1 million metrics from over 5,000 targets, and the scrape interval is 10 seconds for most of them. As you've just seen, some even 5 seconds, and granted, some a little longer. And we have a data retention time of 50 days on that server, and it only utilizes 250 gigabytes of disk space, which is nothing. So if you think more data might help you, you should probably go ahead and just add it. The next exporter, the SNMP exporter, also already mentioned that in one of the examples. What it does is use SNMP to monitor all your network devices, and for us, that mostly replaced what we were using Cacti for. What's noteworthy about it is it's somewhat of a pain to configure, but I have to point out this is not the exporter's fault, of course, but more SNMP's fault. We're still trying to figure out some of the more vendor-specific parts in our SNMP tree, but nevertheless, the exporter actually comes with some tools to help you set up the Prometheus configuration, so it does its best to mitigate that. Once you get through the process, you actually get awesome data and awesome graphs almost right away. It's very easy to create nice dashboards with Grafana, just some example. I would say it's even more powerful than the graphs you get from Cacti. But, there's a big but. For us, Cacti's killer feature was certainly the weather map. And the weather map is actually a standalone open source project that just acts as a plugin to Cacti. However, it has very powerful and very dense visualizations of your network. So naturally, we wanted to have something to replace this. And as it turns out, Grafana actually has a diagram panel type that, sort of does diagrams. So we figured maybe we can give this a try. However, yeah, we haven't quite gotten it to be what we want it to be yet. You can see an example here. It still contains a lot of information, but it's absolutely, we can't get it to be as dense as the weather map, and also it's unidirectional. So yeah, it's not quite what we want yet. So here goes. If any of the weather map people are in this audience or ever see this on video maybe, the weather map is already programmed to support multiple data sources. So if we could have a Prometheus data source for the weather map plugin, that would be amazing. And obviously, we'd also still need Grafana integration, but I think that is actually the easier part. So yeah, if anyone wants to beef up their open source karma, I think this would be an amazing project. So next pro tip. Somewhat related to this exporter, why not build a dedicated long-term Prometheus server? Long-term data is not a primary concern for Prometheus, but there's a very simple workaround, actually. You just build a separate server from the one you're using for your primary monitoring, and you only scrape a very few selected metrics that you think might be interesting for long-term, and then it'll use very little disk space, so you just yank the retention time way up. Think like 2 years, for example. If you do that, make sure you do backups, because otherwise, if something happens, you lose all your data. But if you do, and you have the data, we think it would be very, very useful. We're thinking, in this case, for example, about the aggregate outgoing bandwidth from our data center, or the bandwidth that we use peering with the cloud providers, for example, to figure out, do we need to buy more links? Do we need to upgrade the links? That kind of stuff. The next exporter is going to be the Collins exporter. However, I want to make sure everyone knows what Collins actually is. It calls itself an infrastructure management system. I think it's more often referred to as IPAM. And it is an open source project started by Tumblr. You can find it on GitHub. And what it gives you is kind of a server inventory and classification system. For example, you can say this server is an application server, this server is a database server, and you get a basic kind of lifecycle management. So for example, the server is being used, the server is not being used right now, this server is broken and in maintenance. So that's what you get from Collins. Now, whenever we wanted to know something about the data we had in Collins, we usually had a bunch of scripts to retrieve it for us, and we would run those occasionally and look at the data and figure out maybe we need to buy some new servers, or but that wasn't actually working out too well. So we figured we should get this data into Prometheus, and there wasn't a Collins exporter, so we wrote one, and we actually just open sourced it, so you can find it on our GitHub org. And yeah, as I mentioned, for us it replaces a bunch of scripts, and now we have this fancy dashboard, which is maybe a bit overkill, but you can see the amount of servers we have broken down by class, which ones are being used, which ones are currently broken. And the dashboard itself is a bit overkill, but it's just more to illustrate the point. The important part is that now we are systematically collecting this data, and more importantly, this for us is also another prime candidate for long-term storage. So just imagine you have this very exact data over the course of 2 years. It will be very helpful for capacity planning for your data center. So this brings me to pro tip number 4. You should write your own integrations. It's super easy. The Collins exporter is written in Go. It's a single source file with only 264 lines. That includes boilerplate, white space, and comments and everything. which is of course due to there being really amazing libraries provided by the Prometheus project that make it very simple to write such an integration. So if there's something that no integration exists for, you should really consider investing just a tiny bit of effort to create one. And if you do, maybe even consider open sourcing it to help others benefit. Next exporter, IPMI exporter. Now, there actually is already an IPMI exporter listed on the Prometheus webpage. However, that one is one of the kind that is running on host, and as such, obviously only works when the host is up and running. What we wanted is to have access to the IPMI metrics, even for hosts that are turned off. So we wrote yet another IPMI exporter, and we also just open sourced that. So you can also find it on our GitHub org. And this one works much like the SNMP exporter, where this is running on one host on our network. And we use that host to scrape the baseboard management controllers of the entire fleet. And this obviously works regardless of whether the host is currently powered on or not. The IPMI exporter is, of course, not very exciting because there's not much to graph or dashboard. We mostly use it for alerting whenever any hardware breaks, like fans or power supplies. So yeah. But nevertheless, there's another pro tip to be found here, and that is Prometheus is primarily only designed to handle numeric data. However, sometimes, especially if you maybe write your own integrations, you find yourself in a situation where you have certain pieces of information that just aren't numeric, but you'd really, really like to get them into Prometheus. Now, luckily, there's labels in Prometheus, which are strings, so there's certainly a way to do it. However, a word of caution, you should always do this with great care. So in the case of the IPMI exporter, for example, we were very much interested in the firmware revision that is running on the baseboard management controllers, so we can, for upgrades and stuff. So what we did, and this is a common approach that some other exporters take as well, we export a static time series, so this metric IPMI BMC info will always have a value of 1. There's no information in that actual value. We just use the labels to have access to the firmware revision, and in this case, the manufacturer ID. So when you do this, be cautious, because if the labels change too often, this will very much confuse Prometheus. But for certain information, if the benefit outweighs the risks here, this is something that is super handy. A similar example, this time from the Collins exporter, a very similar situation is when you have certain states, and if you have states and you have to encode these as a number, then you often get the idea maybe we should use a magic number. Don't, it might become very complicated. Another approach is using labels and static time series again, and if you want to know more about the details, you should read the README of the Collins exporter, where it nicely explains how these states are being represented and how it makes certain queries very easy, because you can actually use the state name in labels, which is much easier to remember than any magic number. Again, where you benefit from this, do it, but do it with caution. Okay, so now that we've gone through all this, we all of a sudden have all this data that we previously had in completely isolated systems in one single system, and so we can actually start merging the data from all these systems, and this is where it kind of becomes fun. And this also kind of becomes a little complex very easily, so I have a somewhat contrived example that's just intended to tease you a little bit about what you could possibly do if you are in that situation where you just can merge all this data. So the example I'll be using here is imagine we want to find out all the servers of a certain type that are not running the latest revision of the baseboard management controller firmware. So what's not running the latest firmware revision? This is very easy to figure out. It's kind of the same example we just used previously. We just query for all the hosts that don't run what we know to be the latest revision. The result would actually be a whole list of things, but I'm just including this one example here that we'll get back to in every query, basically. On the other hand, it is very easy to find out all servers of a certain type. I'm going to use the type app2 here as an example, which is just some classification. So again, this query will return a whole list of things, namely all app2 servers. But again, it'll include the one I'll be using as example here. And you see it also, because we also exposed that in colons, it'll contain a label called IPMI address, where it has the same value as the instance label from the IPMI exporter. Now you can already see where this is going. We want to merge this. But to be able to do this, we actually need to make sure both key and value of the label are the same. So we're just going to use the label replace function in PromQL and replace the instance label in the IPMI metrics with the IPMI address label. And you'll end up with an IPMI metric that all of a sudden not only has the firmware revision, but also the IPMI address, this time in a label called IPMI address. So once you have that, you can easily merge these two metrics using the grouping functionality in PromQL. And you'll end up with a result like this, where you all of a sudden have a metric that doesn't have a name, but has all the labels you're interested in, namely the firmware revision, but also the type of server. Now again, if you were to do this on your entire server inventory, this would actually be a list now of all the servers that are of class app2 and are not running the latest firmware. Now to keep going, you could just group again, for example, on the colon state, because maybe you want to know, are these servers actually being used at the moment? And so for this very example, it would all of a sudden add another label, status, and yes, this server is currently allocated, so it's being used. And you could keep going and going. For example, I mentioned earlier that we also have some of our chef data in Prometheus, so I could actually start looking at what chef roles is the server currently operating at. The sky's the limit, basically. So even if this example may not seem entirely useful for you, it's just kind of intended to get you thinking about what you maybe could do if you had all this data in a single data source. All right. So as promised, I'm going to get back to our list of monitoring systems. And as you can see, we've actually gotten rid of quite a few of them. I have just a little cross across StatC, because we're not actually using it for infrastructure monitoring anymore. However, we as the infrastructure team have to keep it running for some very legacy services that we need to support. So yeah, kind of think of it as being gone. Graphite and CloudWatch are a little special, so they're probably going to stay around for a while, but I'll talk about that on the next slide. Everything else, gone. So to look at the breakdown that I had earlier, this is now super simple and super consistent. So we still have CloudWatch, because CloudWatch is a little special in this list of monitoring systems. But for everything else, we just have Prometheus for the data. We dashboard everything in Grafana, and all the alerting goes through Alertmanager. So super simple, super consistent, very nice. So what's the deal with CloudWatch here, and also Graphite? There is actually a CloudWatch exporter for Prometheus. However, CloudWatch is a little special, as in that it only guarantees convergence of your metrics once they're 15 minutes old. That is fundamentally incompatible with how Prometheus operates. In Prometheus, it scrapes a value, takes that value, it's read-only afterwards. So you can't ever change this. So the CloudWatch exporter for Prometheus actually does this curious thing where it'll only collect metrics that are already 15 minutes old, which is not great. You could argue, okay, but you could just use Grafana because it has a CloudWatch data source and look at everything in Grafana at least. We don't do that either, because actually each query to CloudWatch incurs a cost. So if you have dashboard monitors in your office up and running, they'll be constantly creating costs. So what we do here is that we'll keep Graphite around for. Graphite works a little more nicely with CloudWatch. So we stuff all our CloudWatch data into Graphite and then use that to show it on dashboards. That just as a side thing. So let's come to a quick summary and outlook. if you're only in here for the summary, you can wake up now. Is it working? Yes, I would say it is, totally. Was it worth it? Yes, I would also say it very much is. So the most interesting question is, of course, why was it worth it? Now, as you've seen, as I've hopefully shown you, there are many, many, many integrations available out of the box. And even if the one you're looking for isn't there, it's pretty easy to write one. So the effort that was involved in this whole undertaking was actually, given the scope, rather little, I would say. I mean, it was still a lot of effort, but we expected things to be a little worse. The good thing is that in the process, both quality and quantity of our monitoring has increased significantly, I would say. We added new stuff, things we hadn't monitored before. We now have everything in a single data source. We can correlate things. It's very nice. On top of that, monitoring and alerting has become much more consistent, so it's much easier for new hires to get acquainted with everything. And I already mentioned that it's easy to merge the data sources. And the probably most important part, the most important point I would like to make about this, and this may not be interesting for you as infrastructure people, but if you look at it from an organization point of view, or a company point of view, all the points I made are actually true across the entire organization, not just for us infrastructure folks. So whenever someone who was, for example, previously an application developer joins an infrastructure team, or maybe the other way around or whatnot, they're facing the same stack for the entire monitoring spectrum. And it's very easy for them to get started and figure out where to go things. For example, even if maybe the infrastructure people aren't around, developers know exactly where to silence alert, where to look for graphs. Yeah, very powerful, very helpful. Some outlook, I already talked a bit about long-term storage and that it's not a primary concern for Prometheus. However, I also already gave you the simple workaround that is probably already good enough for most use cases. However, if you want to get more into the details there's actually also a remote read-write interface in Prometheus that you could use, for example, to write out historical data to other time series databases, for example. And there are some new features in Prometheus 2.0 that facilitate external solutions for such long-term storage. And if you're interested in such things, then you should probably check out the Thanos project, an open source project that builds on these new features and allows for all kinds of things. Also possibly of interest, there is an open metrics working group that is trying to establish a standard. And this standard is very much influenced by, if not even based on, Prometheus or the Prometheus data format. So if this were to become an actual standard, of course you could be hoping to see even more adoption of Prometheus, or in this case open metrics, maybe, hopefully, maybe even network device vendors, who knows, one can dream. If you're interested in such things, the working group is operating on GitHub, and everyone is welcome to participate. So, that actually brings me to the end, probably pretty fast. Sorry about that. Thank you. But I guess it means we have more time for questions, should you have any.
Absolutely. So are there any questions?
Hi, so on the topic of standard proliferation, how is open metrics relating to the Metrics 2.0 initiative that the graphite people had a couple of years ago at least, and had maybe died right now, I don't know?
I don't know, to be honest. I am not very involved with that working group. I just felt it was necessary to point it out. I mean, first of all, it was initiated out of the Prometheus ecosystem, so I'm not even sure those people themselves are aware of this other working group. Yeah, I do not know, sorry.
I have a couple of questions. The first one is how do you deliver exporters to the physical machines? And I believe that you have some network devices, so if you deliver some exporters to the network devices also, it would be interesting to listen to.
Sorry, could you repeat just the last part?
Yeah, so if you deliver the exporters to the network devices, how you do so?
Okay. Yeah, sorry. We don't. So if I understand the question correctly, we don't do that. I'm sorry if I gave you the impression. So how it works is for example, the SNMP exporter runs on a regular server in our network that we dedicate to running this exporter. It just has special network configuration that allows network access to the monitoring ports of the network devices. So when Prometheus scrapes this exporter, it will tell the exporter, I now want the data from router X. It will then initiate a network connection to router X, get the data from that router, transform it into the Prometheus data model, and return it to the server. So there's no additional software running on the routers. Okay. We just use the existing interfaces of the network devices.
And how do you deliver a node exporter actually to the normal servers? I mean, is it a Docker container, or do you use some kind of a pre-built packages in the system? Or
yeah, we just install the binary, and this is all done by our configuration management.
Okay, thanks.
You're welcome.
More questions?
So you mentioned in the beginning that there are timestamps. When I'm running in a high available setup, do both instances sync their timestamps, or do they resync gaps when one of the nodes crashed? Gaps in their monitoring data.
You mean if I have redundant servers monitoring the same thing? No, they will have slightly different views. I mean, you scrape in 10-second intervals on both of them, and I mean, statistically, it's very unlikely that they scrape at the same time, so most likely they'll just have slightly different data points. If you wanted to, you could use the federation feature instead, which would actually which would include syncing the timestamp to the other server, but we don't do that. I mean, I'm not sure if you would see any value in that, but you could do it.
Any other question? Okay. So thank you for now. Again, thank you, Conrad.
Thank you.